the harvesting system. Before we start, let us introduce ourselves. My name is FAIRUZA from GHAZI.
My name is ABDIKAFI.
My name is MAHFUDH SATRIA.
Okay, so we're going to start our presentation. Here's the table of content of our group project. There's so many, maybe you guys can read it by yourself. So we move to the next slide. Here's the needs for our group project. Palm oil industries need a device for harvesting palm oil. Developing an efficient cutter for cutting the fruit bunch, reducing the operator's efforts in executing the harvesting operation. A good motorized cutter should have the following characteristics. Here's the three components that we must follow the characteristic. Ease of handling by the operator. The second, efficiency and speed in cutting. And the last one, increases productivity as compared to manual harvesting. Here is our SDG goals. There are 17 goals that, in the industry, and then our product meet to the 9th SDG goals, which industry innovation and infrastructure. The goals is industrial innovation and infrastructure, aims to build resilient infrastructure, promote sustainable industrialization, and foster innovation for a long-term time. And the third and the last one, help small-scale industries. And this is our objective, to provide a machine design which works more efficiently to increase productivity. And then to machine should be comfortable in handling to provide favorable ergonomic design. Next slide will be continued by the friends.
For the scope of our project is the first one is cutting edge machine for harvesting of palm oil fruit bunch, and the second one is the machine design is applicable for cutting fruit bunch of palm that range from 4 until 9 meters. For our problem statement, this study aims to identify and design a new fresh fruit bunch or FFB harvesters in plantation that can increase product production and improve worker time. This is for design statement. The design should have following features. The first one is design should be optimal. The second one is it should be efficient, and the last one is design should be reliable. And for project methodology, following will be the method using during the design process. That is have 7 points. The first one is engineering drawing. The second one is product design specification. That means requirement for our product. Next is function decomposition. After that, that is a morphological chart. That means we make a function option for our function. Next is conceptual design and drawing. After that, that is screening and scoring methods. That using for choose the concept, the best concept for our design. The last one is CID design using AutoCAD, SolidWorks, and SketchUp.
Background introduction is palm oil system of freestyle design project, which is extracted from the feed oil palm tree. It originated from West Africa and first recognized during the year of 1917. The uses is palm oil is mainly used in stem oil, is used in edible oil. It's also used in skincare and cosmetics. And the biomass of the oil palm is used for diesel biogas. For harvesting, oil palm is an old tree and it's been harvested since it's long. Mostly sickle has been used since age to harvest fruit bunch. Mainly manual was used to harvest, but currently new machine harvesters are in the market to make the harvesting easy. This one is sickle and the other picture is chisel. The ripeness, all palm fruit takes about 5 to 6 months to ripe after the germination. The blackish green or purple black shows the unripe one. Reddish orange color shows the ripe fruit. Moreover, the unripe fruit is orange to green color. Palm tree. The oil palm tree carries a single stem. It can gain a height of tall as 20 meters. The economic lifespan of the oil palm ranges from 25 to 30 years. The existing technology. Currently, manually operated single harvesters is the most common and widely used in the market. It works with engine but operated manually, operate with the ball to make it reach and cut. Ergonomics. The current design is not much favorable for the workers in terms of ergonomics, as holding machine and long-term vibration can harm the operators. Now, product design specification. Performance. To be flexible with different working positions of the workers, should be easy for workers to handle. The length of the board should be adjustable so it can be changed according to the requirements. The cutting edge should be efficient to increase production. The length we are considering is 4 to 9 meters, and the cost it should be range of 1,000 to 2,000 meters. Maintenance, minimum maintenance should be needed. Finished product should be also rust and corrosion resistant, so continuous usage can be ensured in the humid environment. Materials, so it will be easy to handle by the workers. It should have a good strength to bear the vibrations and the shocks. Next, aesthetics. The design should represent robustness, compactness, and reliability. Our customers should be the oil palm cultivators and planters. The weight should be the range of 6 to 9 kg. The maximum allowable overweight is not more than 9 kg. Life in service is our rate is 5 years. Reliability, the maximum failure rate should be 3% over the service life. Safety should not have sharp protections or aids. It should be capable of being set up and handled with gloved hands. Next, we have product life is 5 years. The backing is standard pallets to abbreviate ISO standards. Time scale production to start 9 months from specification date. Environment temperature ranged from 20 degrees Celsius to 100 degrees Celsius distance to water. Sound, dust, and wind, wind, ice, rocks. The market for our products is worldwide, more dense in tropical regions. For testing our prototype to be proven to meet PDS testing of production models and samples is also required. Ergonomics must be convenient to handle and store, easy to set up and dismantle, and be capable of set up one person, easy to carry by workers. Patent and manufacture facilities, adequate capacity and suitable tools available. Company constraints, we are not considered by this one. So next, MAHFUDH culture.
Here is our MAHFUDH culture. The function contains 5 components: cutting, reaching one, holding, switching, and power. Each component has 4 options: effective power. So here are the 4 options. And for cutting, we use scale, chisel, and the saw. And the holding, we have the handle and the other 3 options. For power, we can use the motor, engine, and pneumatics. So from the morphological chart, we combined and made design. Each person made 3 designs. So this design is from RANA. This one is from OMAR, and this one is from GHAZI. This one is from MUJI. This one is from me.
Here is you can see our screen. So screening is basically done on specific selection criteria. We put the weightage for that one, and data is considered as 0. Further, for each of the concepts, because each of the person got made 3 concepts. So screening and scoring is done on three of these concepts. We choose to choose like 0 as the datum, positive 1, better than datum, and negative 1, less than datum. Next. Here is our scoring method. So based on our screening actually, we choose 5 concepts, 1 concept from each of the person, and further we give the scoring based on those 5 concepts. Here we have given the weightage actually to each of the selection criteria. Further, we have given the rating and weightage to each of the 5 concepts, and the rating for the datum is selected as 3. Above 3 is better than datum, and below 3 is bad than, not much better than datum. Next. So here is our final concept. We are basically using an engine to make it ergonomically better design. We are using 2 of the handles. One handle is this one is inclined one actually with 2-sided handles. So based on the easiness of the worker, it can be held from different sides. Furthermore, we have a rod actually which can be turned, which is like an arm. So this is because we want to increase the range of the harvester. So for our design, we are concerned with 4 meters until 9 meters. So just like you see the arm of the excavator, it has a different range. So we are considering the same concept. And other than that, for the front rod, we have given another specification. It will be extendable. So this one is more versatile to cut short and the long ranges, and definitely it has a range, so you can perform in that range, which in our case is concerned with 4 to 9 meters. Furthermore, for the sickle, we're just using the normal sickle currently used in the market. Moreover, we're considering to put a ball and socket joint at the sickle, so it can be rotated based on the easiness of the work. Sorry. Based on our project specification and design, we conclude an optimal and applicable design is presented to be used as commercial scale by the market.